It's a little puppet too. That's a Tony little puppet. Yeah. Nice and easy. Good speed.
If we need to come down, we'll do so, and we'll thread in underneath the GASPA pole, GASPA arm, and get
Good afternoon. Thank you for joining us here at the Johnson Space Center for this briefing on the James Webb Space Telescope. Before I introduce our panel, let's learn a little bit more about the telescope.
Webb is truly a civilization-scale mission. It not only changes what we know, but how we think about ourselves.
It will pick up where the Hubble Space Telescope and Spitzer Space Telescopes left off in their capabilities.
And it lets us see out through 13 billion years of cosmic time to look at the first generation of galaxies that formed after the Big Bang.
It will also look at these worlds out there, exoplanets, that may or may not harbor life.
When the Webb telescope gets to space, it will be operating in very harsh conditions, in a vacuum and very cold. So we have to test that on Earth.
At the Johnson Space Center, their Chamber A was used to do the thermal vacuum test.
Chamber A was built for the Apollo mission. So they tested the Apollo spacecraft in it. And for the Webb telescope, we have totally taken that chamber and repurposed it. It's a multi-story thermos bottle in which we can pump all the air out and then chill it very cold.
This critical test has been planned for a long time. It was a very long test, and we passed with flying colors. Webb is a partnership between NASA, the European Space Agency, and the Canadian Space Agency.
Science is international because we bring the best to the table that everybody can offer.
And it really takes a planet to make a telescope like Webb.
It's pushing the limits of technology, and it's going to push forward the limits of science.
It's an incredibly powerful tool to take the next step in space exploration.
You know, I really feel fortunate to be living right now and be at NASA right now, because for the first time in history, we can address the question, are we alone in the universe, scientifically, with Webb as a major tool.
And with us in studio today, we have Dr. Ellen Ochoa, the director of the Johnson Space Center. We have Bill Oakes, the Webb project manager. Jonathan Homan, the Johnson Space Center project manager for Webb's Chamber A testing. And Mark Voitin, manager of Webb's Optical Telescope Element Integrated Science Instrument Module, also known as OTIS. Dr. Ochoa, would you like to start?
Sure. It's really a pleasure to be hosting this event at Johnson Space Center now that this very demanding test of the James Webb Telescope and science instruments has been successfully completed. You know, as you know, we're mainly focused on human spaceflight here at Johnson Space Center. However, NASA centers collaborate with and depend on capabilities at other centers. So Goddard Space Flight Center determined a number of years ago that our Chamber A would be the best choice for this test, once it had been modified to support the extremely cold temperatures and the other requirements that were needed for the test. Interestingly, during the time that we have been testing here, including the Pathfinder tests over the last couple of years, Goddard's acoustic chamber was used by Boeing to test the Starliner crew module for the commercial crew program. So just another example of looking across the agency for the right capabilities. But we have been really privileged to be part of this program. The telescope and the integrated science instruments arrived here last May. And then the Chamber A's 40-foot diameter door was actually sealed on July 10th and unsealed on November 18th. And the completion of this test is one of the most significant steps in the march toward launch. You'll hear from others on the team and that the team and the chamber performed wonderfully during Hurricane Harvey, thanks to thorough preparation for hurricanes and other emergency events. I did especially want to thank the folks that were here from Goddard or actually from other places around the country in support of the testing, all the non-Houstonians, because they really, in a way, became Houston citizens for a short time, and they chose while they were here to help out with Harvey recovery efforts in a wonderful spirit of community. JSC was the final stop in testing the telescope and science instrument system performance before launch. Its next stop is Northrop Grumman, where the combined telescope and spacecraft will undergo additional testing, and then on to French Guiana for the launch. So I'd like to turn it over now to the James Webb Space Telescope Project Manager, Bill Oakes.
Thanks, Ellen. Before I get started, I do want to acknowledge we have numerous members of our outstanding JWST team sitting here in the audience today. And what I'm going to do is really look at this test from more of a big picture perspective, discussing what it took to execute the test, as well as issuing some very well-deserved thank yous. Both Jonathan and Mark will be talking more of the details of the chamber performance and the actual test itself. OTIS is the integration of the JWST telescope and its science instruments. This cryo test, if you're down at Johnson, with Goddard leading the OTIS flight hardware testing and JSC leading the chamber execution and operations, really completes the final phase of OTIS's environmental test program. The successful completion of this test represents a very significant milestone for JWST, as Ellen said, as we're marching towards launch and on-orbit operations. It verified the alignment of the telescope to the science instruments, the image quality of the telescope, as well as confirming the thermal performance of the telescope. And in the end, I'm very pleased to say that we now have verified that NASA and its partners have an outstanding telescope and a spectacular set of science instruments. The successful execution of this test, of a test of this magnitude and complexity, did not come easy. It took about 15 years of planning with thousands of hours of engineering meetings and independent reviews. It took an outstanding team to refurbish a chamber constructed during the Apollo era into the world's largest cryogenic chamber, and the construction of a brand new clean room. The complex optical test equipment required for testing took thousands of hours of design, manufacture, and test. Thousands of hours of chamber certification and risk reduction testing were executed to ensure optimal performance of the chamber, the optical test equipment, procedures, and personnel. The actual test took over 100 days of 7x24 operations, involving folks from all over the US, Europe, and Canada, and involved 2 dynamic NASA centers working together as one. And as mentioned, it survived Hurricane Harvey. The folks stationed here at JSC and those here from Goddard and our partners showed unbelievable dedication to ensuring safety of personnel and hardware during the hurricane. For those stationed here at JSC, who continued to provide outstanding support to the test despite threats to their families and homes, I cannot thank them enough for their dedication. Secondly, the folks here from Goddard and our partners banded together as any family in an emergency and assured each other's safety as well as the safety of OTIS. And as mentioned, finally, after Harvey subsided and testing was back to normal, about 20 folks from the JWST team went out back into the community that has supported them all these years and volunteered to help as needed. I do want to take this opportunity to thank JSC for all their support over these many years, along with their major contractors, Jacobs Technology, PAE Applied Technology, the Aerospace Corporation, and Lind. I want to thank the Goddard team and our major contractors for OTIS, Harris Corporation, Northrop Grumman Aerospace Systems, Ball Aerospace, the Space Telescope Science Institute, ATA Aerospace, and Sierra Lobo for their contributions. And also want to thank our partners from the European Space Agency and Canadian Space Agencies and their contractors for all their help and support. Finally, I want to recognize and thank the families, the spouses, significant others, friends, etc., of the JWST team members. We could not have been successful without the sacrifices and support you have provided all these years, for without you, our team could not have made this test successful. With that, I will turn it over to Jonathan for him to tell you about the chamber performance.
All right, thank you, Bill. Yeah, I'm Jonathan Homan. I'm definitely really both proud and humbled to be part of the test and the success, and to be part of a team here at JSC that did an excellent job performing the test, and also worked with the great program leadership that was, like I said, led out of the Goddard Space Flight Center. This test is probably the most complex cryo vacuum test, and definitely the longest cryo vacuum test that we have ever done at the Johnson Space Center, the longest one I've ever been a part of. And during it, like was mentioned, the chamber, all the chamber systems, and the teams, both from Johnson and Goddard, worked together very well to prove that we are delivering a telescope that is ready to meet its groundbreaking science objectives. Speaking of the JSC team, that Bill had mentioned, folks were on shift for well over 100 days on 24/7. During that time, we met all the program's performances, maintained extremely tight thermal requirements, both for a profile and stability. We did have some facility issues, but none of those issues disrupted the program schedule on the test timeline. And for the most part, the test was probably seemed kind of mundane. So, you might go, oh, great, it was boring, but a boring test from our standpoint was very good. And it's a real testament of the years of planning, the engineering that was done to make the modifications be successful, the planning from our test to operate directors and technicians and engineers to put together really good procedures, and also a lot of thoughts of planning for anomalies and off-nominal situations. And I have a lot of wisdom I felt from the program deciding to do the Pathfinder series of testing that we did in both 2015 and 16, and those tests really let us wring out a lot of hardware, a lot of operations issues, and let the program get a taste of severe Houston weather so we could be ready for the flight test. So speaking of that, as mentioned, Harvey came. Harvey was not the hurricane that we planned for. It was I think world record, at least for Houston, in terms of a rain event, and we definitely experienced that, and we were prepared for that. Why that happened? We had spent probably more than a month to get the chamber and the telescope down to its test temperatures, and we were ready for testing. It was the primary part of the optical testing, and I'll let Mark speak more on that. But the telescope did not know, and the chamber did not know that there was an event going on outside its environment. It maintained 20 degrees Kelvin, that's minus 423 degrees Fahrenheit, held those conditions without any incident. With that meant that helium refrigerators were operating, cryogenic liquid nitrogen systems were operating, vacuum systems were operating, lots of telemetry, data systems, control systems were operating. We did have the building took some water hits, and I also just really wanted to thank the team that was on shift, both from the Goddard side and the JSC side, to alleviate issues. And our center operations was extremely responsive to deal with those problems and protect our hardware and get us going. The Goddard team did not stop testing. They used that time and made great progress during the time that our center was closed. And as mentioned too, with that we had lots of foreign nationals, lots of people traveling here, and when people had time, I was so just honored and blessed to see that they used their time away from the testing to be part of the Houston community, to serve with the JSC list to help families that were affected from Harvey from JSC, and also work with some of the local resources and churches to help just local families out. And that was just a real blessing to see that. So accomplishing this test here at Johnson was a major milestone for the program. And as many of you know, and as mentioned, Chamber A is a National Historic Landmark because of what it did for the Apollo program, essentially testing the Surface and Command Module in its space-like environment as it traveled to the moon and back. Now it gets to be a great part of history again, as it has tested James Webb and will be part of that great mission. But from Johnson's standpoint, again, now NASA and the Johnson Space Center does have a facility that has unequaled type of performance. It is ready to be able to support future science or exploration type missions, and ready to be a part of NASA's future. So With that, I just wanted to again say that I'm really grateful for what we were able to do, and I'm going to pass it on to Mark a little bit to talk about the optical and telescope portion. So this is Mark Voighton. Thank you.
Great. Thanks, Jonathan. As you can see from Ellen, Bill, and Jonathan, they've all clearly conveyed the fact that we're extremely elated to be here, especially after the successful completion of our cryovacuum and optical testing of the world's most magnificent time machine, the Webb telescope. As you can imagine, an endeavor of this magnitude does indeed require the extensive planning, execution, and coordination of a cast of hundreds. Has been mentioned, it's a completely collaborative effort, and the collaborative spirit is rooted in the great teamwork from all the partnerships that have been forged between the NASA centers, our international agencies, their domestic partners that include all of the contractors and several universities, all of which have been mentioned in detail by Bill. And as you can imagine, the cooperation of this extensive team helped prepare and execute each phase of the telescope's integration and testing during its journey towards launch in 2019. As you know, last May we arrived, and with the arrival of the optical portion of the Webb Observatory here at Johnson, both Goddard and Johnson team members greatly anticipated the final and most complex test of the flight hardware to date that will be conducted here at JSC's historic Chamber A. The optical telescope element, an integrated science instrument module, otherwise known as OTIS, it's a lot easier to pronounce. It arrived carefully in a carefully engineered space telescope transporter for air, road, and sea shipping container, and was moved into the clean room in Building 32, where it was lifted onto the rollover fixture to be prepared for its test in Chamber A. Once it was in Chamber A, we roughly spent about a month cooling down to 40 Kelvin, or minus 233 degrees Celsius, and this was done in the world's largest space freezer, Chamber A. Once we got it down to temperature, it was time to get down to business, and we had a number of test objectives that we were able to achieve. I'll share a few of those with you. First of all, we proved out that our primary, secondary, tertiary mirror, as well as our instrument modules, are all aligned and aligned per the requirements. The next thing we proved was that the primary mirror, which as you know is made up of 18 individual segments, all operated together. 18 segments clearly appeared to be operating and aligned as one 6.5 meter monolithic mirror. That was a very large accomplishment in this test. We also proved, as Bill mentioned, that the thermal workmanship required to manage temperatures in all regions of the telescope and the instrument module was performing as expected. Also, we exercised a number of operational procedures in a day-in-the-life testing that simulated observation sequences and activities that would be similar to what we would do on orbit. The next thing we did is we confirmed that our integrated fine guidance system can track a simulated star through the complete optical system and adjust the position of our fine steering mirror to maintain correct observatory pointing. The next thing we did is we continued to confirm that our instruments are operating properly and functioning properly by completing their comprehensive performance test on each of 4 instruments. And lastly, for the very first time, the light of a simulated star was seen through the whole optical telescope and detected by each of the 4 instruments. So as you can imagine, as been mentioned, this was a very large effort. The expertise required to execute this test required more than 100 team members every day to maintain 24/7 operations. And as you know, it spanned a period of 100 days, and the actual test time started on July 13th and ended on October 21st. During that time, we executed over 100 procedures, and they varied in length from 30 pages to, yes, over 1,200 pages each. So a lot of paper if you would have printed those out, and we did. And although we didn't really prepare for Hurricane Harvey, we really were well prepared. As Jonathan mentioned, all of our preparation and the risk reduction testing done in the couple years before and the exposure to the inclement weather and the severe weather that Houston had to offer really did prepare our team to make critical decisions during the storm. And as a result of all that preparation, key decisions were made that really were able to maintain personnel and hardware safety during the storm. So after we completed the test, we warmed up to room temperature and returned to 1 atmosphere, and that took about a month. We spent a little bit of time evaluating Otis while it was in the chamber to make sure that it was still in the correct configuration to be safely removed from the chamber and rolled out and continue its processing and deconfiguration effort to lead us up to where we are this month. So at the end of this month, we will pretty much complete our time and effort here, and Otis will be carefully lifted back into STARS, the shipping container, and it'll begin its journey to Northrop Grumman in Redondo Beach, where it'll be integrated with its spacecraft element. So that'll also include the spacecraft bus and the sun shield. And together, for the first time as a complete observatory, JWST will endure its final acoustics and vibration testing prior to its shipment to French Guiana, its final earthbound destination prior to launch. Now, I also want to thank everyone. I certainly want to thank the whole Otis integration and test team for just an absolutely amazing performance over many, many years. And during the 100-day test, really having to stay at the job at hand and stay focused through all of it. It was an amazing effort to watch and be a part of. And I'm certainly proud to have worked with each and every one of you, and we couldn't have done it. You guys represent the best of the very best. We would not have achieved what we did without you. But the one thing that I do feel very proud about is that I think we really have left, we will leave Johnson, and we will be in a position where the optical portion of the magnificent space telescope, that's Webb, is going to be ready to unravel the mysteries of the universe. So, thank you.
Thank you, gentlemen. We will now go to questions. We'll start with reporters here in the room. Then we'll take some from the phone bridge. And if we've got some time, we'll take some from social media. If you'd like to ask us a question on social media, please use the hashtag AskNASA. So here in the room, Mark.
Oh, thank you. Mark Carreau from Aviation Week in Space. Sorry about that. Mark Carreau from Aviation Week in Space Technology. Could you go over the cold vacuum soak, how many days continuous? I guess I'm a little confused on whether that could be broken up or it needed to be continuous, and if you're able to do that. And then could you speak to when the hardware will leave in a time frame, even roughly, how it will transport? And I know there's some discussion in Washington about the budget and continuing resolution. Would that, if there was a shutdown, have you prepared for that like you did for Harvey, or how would you deal with that? Thank you.
I'll take that one. They can take the rest.
Okay,
I'll take the timeline.
We probably could both answer that, but Jonathan, take that.
So it was essentially a single thermal cycle, and it was a cryogenic only test. It spent about 30+ days to get it down to temperature. We spent about a month at 20 Kelvin to complete those objectives, and then about a little bit more than a month again another month to warm back up. Does that answer your question? Okay. I'll defer the next part of it.
So which piece do you want to address next?
Shipping.
The shipping.
So roughly, as I mentioned, we're finalizing our effort here. We've stowed all of the wings, and everything that had to be stowed is complete. We're entering into the final couple weeks. So at the end of January, beginning of February, we will load into the shipping container, move over to Ellington, and then be loaded onto a C-5 and journey to Northrop Grumman.
Okay, so as far as the question on the CR goes, right now, given where we are, the CR wouldn't, a government shutdown at this point would not be a major impact. We can define, if we're in the middle of critical operations here, those would continue to go. We had the last time there was an extended government shutdown, we were in the middle of testing our instrument package in a cryovac test, and we were able to keep testing during that. As far as the work out of our contras, for example, at Northrop Grumman, they are funded beyond that point. So they can keep working until that funding runs out. And we'll be working out over the next few weeks about how far that takes them. But right now, there would be no immediate impact.
Any other questions from the room? Yes, sir.
Eric Berger with Ars Technica. Tell me more about if you would, the simulated light from a star. How did that test work out, and what was it? What were you hoping to find out? And it sounds like it was a success.
Okay, yeah, I'll answer that. Let's see. So yeah, that had to do with our fine guidance subsystem, which is used to ultimately, at the end of the day, once you go into a maneuver and start an observation, you want an all-out movement of the observatory. So what this test did is it directed light through the full optical train. That light was then, a centroid was generated to determine the position of the light. That centroid was shared back through the attitude control system, which then determined how much to move a mirror to track that star. So that's exactly the first time we effectively closed the loop on the complete fine guidance subsystem and proved that we can actually track a star and update its position every 64 milliseconds or 16 times a second, which is of the proper bandwidth to be able to maintain stability during our observations and to continue to maintain observatory pointing during an observation.
So what was it like in the room, Mark, when you guys finally got that confirmation? What was the attitude?
Oh, there's so very, a very specific, everybody has roles and responsibilities, so a very specific part of the team, the fine guidance team, was elated. There were texts coming out at a regular rate, the fact that this was the first time over a tremendous number of years of planning and simulating and doing piecewise tests of the various components. If you can imagine a loop closing, every piece of that loop had to be tested independently, and then seeing it all come together in this test at temperature really was a completely fascinating moment, and everybody was actually happy that the loop closed and we were able to track the star, the simulated star, I should say, which really was from a source in our ASPA, which provided that light into our system.
Robert?
Robert Perlman with CollectSpace.com. I think when Otis arrived here, it was still set for a 2018 launch, a launch this year, and it's now out into 2019. Given that schedule, was there any change to the schedule while it was here? Are you taking more time to ship it, or where does that extra time play in between now and launch?
There was no change to the schedule here. Anytime you have something like that, you want to keep everybody marching to their schedule, right? Time is money, so I don't want to really spend more time here testing, because then it's going to cost more money, and that money is going to be needed to pay for the launch delay. So what will happen is when we ship from here and we head out to Northrop Grumman, we will complete our post-ship functional testing out there, and then basically it will wait for the rest of the observatory to catch up to be ready for observatory integration.
And it was mentioned how Chamber A is now ready to support additional future projects. Is there anything pending going into Chamber A now that it's upgraded? Is there any specific next program that's going to use?
There is nothing specific. We've been looking at different things with both Orion and commercial cargo, commercial crew type of things are there, as well as we've met with some of the future science missions to talk about, how they might possibly use the chamber for some, like I said, the next generation type of science observatories.
Any other questions in the room? All right, we'll go to the phone bridge. For those on the phone bridge, please press *1 if you have a question. And if your question's been answered, please press *2. And we'll go with Sarah.
Hi, this is Sarah Lewin from Space.com. I was curious if you knew about the nature of the most intense tests in store for the rest of the telescope beyond the optical element.
You want me to?
Yeah.
Okay, so you're looking at the future going forward. When we get forward, right now out on the West Coast, I'll kind of walk you through the timeline, and I'll highlight the ones where we would say we have the most worries. We are finishing up the folding and stowing of the sun shield after a successful deployment this past fall. When that's completed, the integrated sun shield and spacecraft will now go through essentially its series of environmental tests. It'll go through acoustic testing, vibe testing, and thermal vac testing. When that comes out of thermal vac testing, it will then go through another sun shield deployment. When that deployment is completed, we will then integrate Otis to the sun shield, and at that point we'll have a full observatory. We then actually fold everything back up again, and then it will go back through environmental testing, but just acoustics and vibe testing. When it comes out of that, we will then do the observatory deployment. And that will be the point where we are doing things now, more things for the first time. It is a very complex deployment. There is a very complex series of ground support equipment to ensure that we are offloaded to simulate deployments in a zero-G environment. I think, at least usually when I always talk and I give talks, there's about 180 devices that have to work for our deployments. We will go through the testing and final testing of those deployments before folding everything back up to put it back in the shipping container to head down to French Guiana. So if you're looking where the highest risk or what makes us the most nervous, it's the observatory deployment.
Thank you.
And looks like we got Bill Harwood.
Yes, thanks. Bill Harwood, CBS News. Just to follow up on Eric Berger's question for Mark. The simulated star testing you did, can you talk a little bit about how the testing shows or proves to you that the optical system will, I'll say, bring light to a focus properly? I'm thinking of Hubble, of course, and how you know this time around everything is going to work the way you want it to. Second question was for Mr. Oxby, wondering how much schedule reserve you have in the system right now between now and launch. Thanks.
Okay, yeah, so I guess I'll break yours into two. You know, as I mentioned, the fine guidance system closing involves a number of subsystems that have to operate properly, and ultimately we have the ability to understand where the light is and where the light is detected within the fine guidance system. So ultimately, the combination of generating the light from our source, which is called ASPA, and having it trace through the complete optical system and be detected centroid and understood where it is, and understanding the resultant motion that was required to move the mirror in response to that star position gave us the confidence we need to know that the system was performing properly. The second part of your question has to do with, it's kind of a general question about how we prepare JWST to not have similar problem that Hubble had. I think the simplest answer is this test that we conducted here is an end-to-end test. The end-to-end test is the one thing that gives us confidence that we will be able to make any adjustments to the mirror and its figure to deal with the thermal profile that we'll see on orbit. The other aspect of our testing that is unique and different from Hubble is that we're testing our Otis with test equipment that was not used to build the various pieces. So we have a completely independent test method apart from what was used to build it. And the combination of those two things gives us the confidence that we will avoid the kind of problem that occurred on Hubble.
As far as the reserve question goes, right now our current launch window starts at the end of March and runs through the end of June. So depending upon where you pick in that window you want to try to launch, it depends on the reserve. But if you're looking at it right now, we're probably sitting at around a couple of months of reserve. I will remind you that back, I guess it was before the holidays, during some congressional testimony on telescopes, Thomas O'Brien mentioned that we have an independent assessment of our schedule going forward at the end of this month. And at that point, the independent team will provide their assessment of our reserve, where we are, as well as in a project assessment, because we continually assess our schedule and the progress being made against it.
I think we have some questions from social media, and just as a reminder, if you're following on social media and would like to ask a question, please use the hashtag AskNASA. Laura?
Our first question from social media is about the chamber. So what changes were required to test the telescope as opposed to meeting the demands for Apollo?
Okay, so Apollo was a kind of a thermal vacuum test. So it had both a hot and cold. So Apollo had a solar simulators and the environment was not as cold as James Webb. So it kind of rotated the Surface Command Module from a solar wall to the deepest space and was able to test the thermal performance of the Apollo Surface Command Module. James Webb did not need to see the sun. The primary telescope is on the dark side of the sun shield, so we needed to create the cryogenic environment, which was much colder. So that environment was probably about 100 degrees Kelvin. We were operating at about 20 degrees Kelvin. We had to build a new helium refrigeration system and a new helium shroud that's about 45 feet in diameter and 70 feet tall that Otis spent those 100+ days in that environment.
Another question is, how does being cold benefit Webb, and how is that different than Hubble?
I'll take that question. So we're different in Hubble in many ways. Two of the bigger ways is, one, we're much larger than Hubble. All you got to take is a look at the size of our primary mirror and the size of Hubble's primary mirror. But the other part of that is, whereas Hubble is a visible light, primarily a visible light telescope, we are an infrared telescope. So for us to be an infrared telescope, we have to be at very cold temperatures to be able to detect the light from the early beginnings of the universe, and as it goes through the universe and goes through a shift into the infrared, we use those cold temperatures to be able to detect those signals coming from the early aspects of the birth of the universe.
Do you have any other questions? Yes, ma'am.
Hi, Irene Klotz with Aviation Week. I have two questions. The first is the issues raised by the GAO report. I think that was in December. Have all of those been addressed, and is there any additional cost estimate of the project with the additional delay announced at then?
Well, the GAO report, their annual audit report, has not been released yet, so I'm not sure which report you're talking about. To tell you the truth, I have an exit briefing with them on Friday. As far as cost goes, right now our costs cover the launch delay. Back in 2011, when we did the replan, we did have the foresight to say, we could slip the launch, so we make sure there's money in the back end of that budget to support a launch delay.
Thanks. And regarding the chamber at JSC, does Goddard pay JSC for that, or how is that? How is that figured in the budget?
That's part of our budget.
Yeah, the testing.
Okay, thanks.
Do we have any others on social media?
What are some of the most exciting discoveries you're looking forward to?
They're all looking at me. I think
the list is long.
Yeah. Well, let's see. None of us are scientists that are sitting up here, so probably what we think is exciting might be a little different than other folks. Personally, I think seeing some of the first light images will be very exciting, but also the exoplanet. I think that's, especially over the last couple of years with the emphasis placed on exoplanets, there could be some really exciting discoveries made there as far as finding some of those planets that already have been identified as kind of Earth-like. Being able to take a look at them on our telescope to see if they have some of the basic elements of life would be very exciting. And of course, and if you talk to any of my science friends and also to us, the biggest, some of the most exciting things that came out of Hubble are the things that were never expected. And that will probably be the same with JWST.
Jonathan, how long did it take you guys to get the chamber ready to welcome Otis?
So we first started talking requirements with the program on details in 2004, and then we were funded in 2007 to start working the requirements. And so essentially the major build was probably from 2009 through 2012. And then we started doing chamber performance testing, and then of course the series of risk reduction testing through 15 and 16. So it's been more than a decade of from requirements to execution.
So you guys really have become one big team between Goddard and
Yeah.
JSC. Do we have any other questions here in the room? Do we have any more on social media? Well, any last thoughts, you guys?
No, we still have it's a very exciting time, but we still have a lot of work in front of us. So there's a lot of excitement ahead. We all hope it's going to be very boring. because boring is good. And we hope that when we launch, the boring is the only excitement should be when we see science. But this has been a great achievement, and like I think we've all said, we want to thank the teams here, the teams from Goddard, from all around the world who've helped out with this, because it's a very exciting time. It's been a little stressful at times, but now we're looking forward to moving forward.
Well, you can now say it survived a hurricane.
Yep. We've survived almost every major natural event except for a couple, and those are the ones that kind of occur in California, so we're worried about those.
Let's not jinx it. Well, thank you guys for being part of the James Webb Space Telescope briefing. If you would like to learn more about James Webb Telescope, you can find them on the internet at www.